All right, books open to page 11. Hopefully you did well on your quiz yesterday. Students in here did a pretty good job on theirs. So just finished going over that with them. Page 11 at the bottom of the page. We practiced with these yesterday, but let's review over these rules. Class, a number is divisible by 2 if the number is even. A number is divisible by 3, Bryson, if...
The sum of the digits is divisible by 3.
Good, if the sum of the digits is divisible by 3. Number is divisible by 4, Sam.
The last two digits are divisible by 4 or they're both zeros.
Good, if it's double zero or if the last 2 digits are a number that's divisible by 4. Number is divisible by 5, class, if the number ends in either 0 or 5. Number is divisible by 6 if, Griffin,
if it is even and divisible by 3.
if it already works to be divisible by 3 and it's an even number. So divisible by 2 and 3 basically. Number is divisible by 9, Paige.
If the sum of the digits is divisible by 9.
And remember, there's not a lot of numbers those digits will add up to either 9, 18, or maybe if it's a really big number, 27. But those are the numbers you'd have to get from the sum of the digits for it to be divisible by 9. And of course, class, divisible by 10 if it ends in 0. So, here's the question. Using that chart in front of you, analyze this number. Write down all of those numbers, 2, 3, 4, 5, 6, 9, or 10, that this number is divisible by. Which of those is 5,732 divisible by? You can do that right there in your textbook. Maybe write it off to the side and just kind of check off the numbers as you go. Is it divisible by 2, 3, 4, 5, 6, 9, or 10? Which ones? That's the question. Is it even, class?
Yes.
Then it's divisible by 2. What is the sum of the digits going to give us, Elaine?
17.
17. Class, can 17 be divided by 3? No, so let's rule out 3. For 4, class, we're only going to look at the last two digits. Can 4 go into 32, class?
Yes.
Yeah, 4 times 8, so it's divisible by 4. 5, class?
No.
It doesn't end in 5 or 0. 6?
No.
Because you ruled out the 3. 2 and 3 both have to work. 9?
No.
No, I mean, if the 3 doesn't, the 9 doesn't have a chance. But again, 9 doesn't go into 17. 10?
No.
No, it doesn't end in 0. So the only things it's divisible by, as far as the numbers that we're working with, are 2 and 4. Do the same thing for this number now. 3,870. 3,870. Which of these is that divisible by? How many say it's divisible by 2? Show of hands. Yes, very good. How many say divisible by 3? Show of hands. Yes, because it adds up to 18. How many say 4? Show of hands. Uh-oh. Does 4 go into 70? Think about it for a minute. Try dividing it by 4. 4 goes into 7 once, right? With 3 left, does 4 go into 30? Evenly?
No.
No. So is it going to be divisible by 4, class?
No.
No. All right, how many say divisible by 5? Show of hands. All right, most of you are on board with the 5. How about the 6? How many on board with the 6? Yep, because 2 and 3 both work. How many on board with the 9? Because 18 is a good one. How about the 10? Are you on board with 10? So this one's divisible by all of them except for the 4. How many had those answers or were on track? All right, one more of these. Let's do 2,145. 2,145. How many say 2? Show of hands, it's divisible by 2. People are like, nah, not so much. No, it's not even, right? So not 2. Divisible by 3. How many go in with a 3? Yeah, what's the sum of the digits, class?
12.
12, so that works. 3 was good to go. How many say 4? What are the last 2 digits, class? 45. Now, 44 is divisible by 4, right? Is 45 divisible by 4? How about 5? We go with 5. Yes, definitely go with 5. 6. Ooh, wait a second. Both 2 and 3 have to work. The 3 works, but not the 2. Nope, there goes 6. How about 9? We go with 9. Wait, what's the sum?
12.
12. Can 9 go into 12? No, 9. How about 10? Does it end in a 0, class?
No.
No. So the only numbers that this one's divisible by, as far as the numbers we're working with, are 3 and 5. How many have just those 2? All right, questions on divisibility rules. All right, let's go and review some things then that we should have learned, really going all the way back to 4th grade, I believe, maybe even earlier, but I think it was 4th grade. You started talking about something called factoring. And let's just take the number 36. There are a lot of different ways to factor a 36. For instance, 1 times 36. But there are other ways as well, and we can use our divisibility rules to help us. Is this number divisible by 2, class?
Yeah.
It's even, isn't it? All right, 2 times what, anybody? Corey? 18. All right, is this number divisible by 3, class? Yeah, we've actually memorized this, right? 3 times 12, right, is 36. Is it divisible by 4, class?
Yeah.
And again, that's when we memorized in elementary school, 4 times 9. Is it divisible by 5, class?
No.
No, okay. Is it divisible by 6?
Yes.
6 times 6. And notice, I've hit the same digit again. So my factors are, notice, 1, 2, 3, 4, 6. I don't need to write it twice. 9, 12, 18, and 36. That's a lot of factors, isn't it? Not all numbers will have this many factors, but they could have a lot of factors. Does that make sense? You just find the factor pairs. Even with a huge number like 108. Well, class, the easy one that we can always get, 1 times 108. Okay, well, that's the easy one out of the way. Is it divisible by 2, class?
Yes.
It's even, isn't it? 2 times 54. I heard somebody call that one out. Is it divisible by 3?
No. Yes.
Add up those digits. 1 plus 0 plus 8 is 9. 9 is divisible by 3. So 3, take a minute. 3 times what? Divide that 108 by 3.
36.
36, good. All right. Is it divisible by 4, class? What's the last 2 digits? 8, basically, right? Is 8 divisible by 4?
Yeah.
Then the whole number is. Take a second. What would you get if you divided by 4? I heard it, 27. Good. All right. And by the way, you don't have to figure things out that fast. So if you're like, I didn't get it, it's okay. We're just for illustrative purposes. You're not normally going to have to deal with numbers this big. Is it divisible by 5, class?
No.
No. By 6?
Yes.
Because 2 and 3 both work, okay? So figure out what it would be if you try to divide it by 6.
36.
18, there we go, yeah. You had it going in one time with 4 left over. I know where you got the 48 from. 18. All right. Is it divisible by 9, class?
Yes.
Yeah, it's divisible by 9 because the sum is 9. This is actually one we've memorized. 9 times 12. Is it divisible by 10? No. And so notice, by the way, we've worked our way all the way around because 10 and 11 are the only 2 numbers in the gap. It's not divisible by 10 or 11. So my factors are, say them with me, class. I'll try to get off to the side here. 1, 2, 3, 4, 6, 9, 12, 18, 27, 36, 54, 108. That's a lot of factors, isn't it? All right, so now here's the other thing though. With factors, right, we have this idea of common factors. Some numbers have factors that are common. For instance, let's just take 36 and 108. Well, obviously, class, all numbers have a common factor of 1. Agreed? But go around. But they also have a common factor, class, of 2, 3, 4, 6, 9, 12, 18, And even the 36, all the factors are common. And that's because this number is a factor of 108. But you're looking for numbers that exist in both pairs. How about a set of numbers that don't have quite so many common factors? Let's try 40 and 100. Let's figure out some factors of 40. Let's start with the most basic, class.
1 times 40.
Does 2 go in?
Yes.
2 times?
20.
20, think money. Does 3 go in?
No.
No, some of the digits doesn't add up to something divisible by 3. Does 4 go in?
Yes.
Obviously, 4 times.
10.
Does 5 go in?
Yes.
Yes, 5 times.
8.
Does 6 go in? No, 3 did. 7 doesn't. There's already an 8. So what are the factors of 40? Class, say them with me. 1, 2, 4, 5, 8, 10, 20, 40. All right, let's go with 100. Obviously, class, 1 times.
100.
Does 2 go in?
Yes.
2 times. 50. Good. Does 3 go in? No. Does 4 go in?
Yes.
It ends in double zero. Think a dollar is 4 quarters, or 4 times 25 cents. Does 5 go in?
Yes.
5 times, think $100. 25 $20 bills. Does 6 go in?
No.
Does 9 go in?
No.
Does 10 go in?
Yes.
10 times
10.
10. All right, so let's say the factors of 100, class. 1, 2, 4, 5, 10, 20, 25, 50, 100. All right, again, we don't repeat the 10, so we did a good job with that. Let's think, what are the common factors? Well, I'm not going to waste my time on 1. I mean, seriously? Whatever. All right, but what other factors do they have in common, class? 2, 4, 5, 10, 20. They have 5 common factors. Which of them is the greatest common factor? 20, right? It's the biggest of them all, right? Do we remember doing this in elementary school? All right, questions at all on what we're doing here? Turn over to page 15 in your textbooks. Turn over to page 15. Now you'll notice they've got a little bit smaller numbers for you to work with here. I want you to do 1 through 6. You're going to start by listing pairs of factors. That's what we showed here, right? Now we did it vertically. You're going to do it sideways. Then they want you to list out the factors in order, and then write out the common factors for the 2 numbers for number 1, the 2 numbers for number 2, and so forth. Doing 1 through 6 on page 15. Okay, so what we did there was pairs of factors, right? So 8, you know, is 1 times, so write that little pair down there, right? 1 times 8. And then ask yourself, okay, can 2 go in? Okay, so it's 2 times. Okay, does 3 go in? No, and 4 is already on the list. So there's you only have 2 pairs of factors this time. So list the factors numerically. Just like we did on the board. Good, now do the same thing for 12. And when you're done, you're going to be able to find common factors, which you'll write off to the side. Yeah. So basically doing exactly what we did on the board. Obviously, we don't have divisibility rules for 7 and 8, but if you know that the 8 or the 7's in there, you know, if they're from multiplication tables you memorized in your younger years, by all means, apply that knowledge here. Once you finish with 1 through 6, once that whole box is done, put your pencil down, look up this way so they know that you're finished. Just about another minute and a half or so. Looks like most of us are just about finishing up the box. Done, Luciana's done, page is finished. Good, Elaine. Michael. All right, let's see how we did. Pencils down. Even if you're not finished with all of them, that's okay. Check the ones you did get done. For number 1, how did you factor the 8? What were your, we're going to skip the pairs of factors and go to the all factors. Does that make sense? Okay, so for the number 8, which is the first number in number 1, what were the 4 factors you had, Michael?
1, 2, 4, 8.
1, 2, 4, 8. What about the 6 factors of 12 right below that? Kirsten?
1, 2, 3, 4, 6, 12.
Good. 1, 2, 3, 4, 6, 12. So the common factors were what, Kirsten?
4,
Well, that's the greatest common factor. There were a couple other ones.
2,
And obviously 1. Yeah, and if you skipped writing the 1, I totally don't blame you because all of them have 1. But 2 and 4 were the other common factors, with 4 being the greatest. For number 14, okay, what were your 4 factors, Ben?
Number 14.
Well, number 2, the 14 in there. What were the 4 factors?
1 times 14.
Not the pairs of factors, the next column over where you listed out the factors in order.
Oh, 1, 2, 7, and 14.
1, 2, 7, 14. Elaine, what were the factors of 18? You should have had 6 of them.
1, 2, 3, 6, 9, 18.
Excellent job. So what were the common factors then, Elaine?
1, 2.
Just 1 and 2. 2 being the greatest common factor. For number 3, the 10 had 4 factors. Griffin?
1, 2, 5, and 10.
1, 2, 5, and 10. And then the 15 right below it also had 4 factors. Paige?
1, 3, 5, 15.
Good. 1, 3, 5, 15. Where the common factors were?
5.
5 and 1. So 5, the greatest common factor. Good. For number 4, the 6 has 4 distinct factors. What were they, Jalen? Number 4, 6, the first number, has 4 factors.
1, 2, 3, and 6.
1, 2, 3, 6. Right below it, the 24 has 8 factors. Corey.
Ooh. 24. 1, 2, 3, 4, 6, 8, 12, 24.
Good. 1, 2, 3, 4, 6, 8, 12, and 24 were the common factors, Corey.
1, 2, 3, and 6.
1, 2, 3, and 6, with 6 being the greatest common factor. For number 5, 20 has 6 distinct factors. Luciana?
1, 2, 4, 5, and 10.
1, 2, 4, 5, 10, and 20. And for the 35, what were the factors? Bryson?
1, 3, 5, and 35.
Well, we're right about the 1 times 35. The other factor should have been a 5 times 7. So we should have 1, 5, 7, and 35, where the only real common factor class was 5. All right, for 49, what did you have for the factors? Did you make it that far? Did not quite make it that far. Paige, I think you were one of the first ones done. What did you have for the factors of 49?
1, 7, 49.
Yeah, 1, 7, and 49, just 3 factors, because one of the pairs was 7 times 7. What about the 77? Elaine, you were also done pretty early. What were your 4 factors?
1, 7, 11, 77.
And so the other than 1, the only common factor was
7.
7. How many got all the ones you did correct? Even if you didn't finish all of them, that's okay. The ones you did, you got right. All right, questions on any of them? Questions on any of them as we work on factoring. All right, flip back, if you would, to page 13. Take a look at page 13. A couple of terms that I think you might be familiar with, but I'll be honest, I don't know that much about elementary to know for sure. Did you talk about prime numbers in 6th grade? Do you know what prime numbers are? I'm getting nods from a lot of people. Excellent. Make sure you note that at the top of the page. Maybe use your highlighter or your pencil to note the definition of a prime number. A prime number is a number with 2 distinct factors. A prime number has only 2 factors, 1 and itself. For instance, if I asked you to factor a 13, well, obviously you have 1 times 13 and that's it, because 13 is a prime number. But when I asked you to prime factor an 8, or factor an 8, well, we had 1 times 8, but we also had another pair, didn't we? 2 times 4. Or even something like a 9, where, okay, we've got the 1 times 9, we also have 3 times 3. Well, that has 3 factors, not 2. This has 4 factors, not just 2. These are what are called composite numbers, and note that term as well. So a prime number class has how many factors? 2. That's 2 factors. Itself times 1. That's all it ever has. A composite number will have more than 2 factors. Now, what about the number 1? How would you factor a 1, class?
1 times 1.
1 times 1. So what are its factors?
1.
Does it have 2 factors?
No.
No, it doesn't. So 1 is not prime. But does it have more than 2 factors, class?
No.
No. Composite numbers have more than 2 factors. 1 doesn't have 2 factors, it doesn't have more than 2. It's also not composite. 1 is just sort of that identity number. It's got no real fit. It's not prime, it's not composite. Think about 0. How do we factor a 0, class?
We have
0 times anything, right? Now, does it have only 2 factors? No. But it's in a weird state, because you could have anything times a 0. 0 is also not prime or composite. Make sure you note that in bold on your in the page there. The numbers 0 and 1 are considered neither prime nor composite. Okay, so those are not prime or composite. Other than those 2 numbers, all your other integers will either be a prime number or a composite number. Now, it mentions in the text there, if you look at the table E at the bottom, it actually lists a whole bunch of prime numbers. Read these prime numbers in the chart, table E, right above the, is that a Lamborghini? Or a Ferrari? I have difficulty telling you what prime. I think it's a Lamborghini. Let's read those numbers together as a class. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. Notice all those numbers we just read are odd numbers. except for one. Which number on that list is not an odd number, Michael? 2. Why wouldn't there be any other even numbers? Sam?
Because when they're even, you can split them in half.
Because if they're even, they have at least a 2 in them, right? Which makes them composite. So note that, and you actually see that in bold up above the blue shaded box earlier. All even numbers except the number 2 are composite. All even numbers except the number 2 are composite. Now, if you have a highlighter, go down to table E and highlight most of that top row. You don't have to highlight the 23, but highlight the first 8 prime numbers. If you don't have a highlighter, I don't know that they would pop off the page without it. So maybe off to the side, write these numbers down. 2, 3, 5, 7, 11, 13, 17, 19. You need to memorize those 8 prime numbers. Okay, we're not going to memorize the whole table E because that's ridiculous, okay? But we are going to memorize the first 8 prime numbers. Let's say them again together as a class. 2, 3, 5, 7, 11, 13, 17, 19. Again, 2, 3, 5, 7, 11, 13, 17, 19. Let's stand up and do it. Get your blood moving just a little bit. One more time. Reciting those 8 prime numbers together. Begin. 2, 3, 5, 7, 11, 13, 17, 19. Now, let's see if we can recite them without seeing them. Begin. 2, 3, 5, 7, 11, 13, 17, 19. Have a seat. Good. Turn over to page 15. Turn over to page 15. Now, when it comes to deciding is a number prime or composite, don't mark anything yet. Just be looking up this way. When it comes to deciding is a number prime or composite, for instance, if we were looking at the number 34, well, that's an easy one. It's an even number. I know there's a 2 in that, right? But maybe a number that's maybe not quite so easy, like, for instance, 51. Is that prime or composite? The best thing to do is think through your divisibility rules. Well, we know, of course, 1 times 51. You don't even need to waste your time writing it down. Is it divisible by 2, class?
No.
Is it divisible by 3?
No. Yes.
5 plus 1 is 6. 3 can go into 6. Okay, so is it prime or composite then? It's composite because something other than 1 in itself would work, right? If we took the number 63, is that divisible by anything besides 1 in itself? Think through your divisibility rules.
Yes.
It's divisible by 3. It's also divisible by 7 and 9. 7 doesn't have a rule, but 9, yeah. So use those divisibility rules to determine, wait, is there something that it could be divided by? Now at your seats, if you would, for numbers 7 through 18, identify the number as either prime, composite, or neither. Here's what I'm going to let you do. Mathematicians are lazy. So instead of prime, you can put a P. Instead of composite, you can put a C. And if it's neither prime nor composite, well, there's only 2 numbers like that, class. What are they?
0.
0 and 1. Those are the only 2 numbers that are neither. But if you see one of those, put an N. At your seats, do 7 through 18. Next to each number, put either a P for prime, C for composite, or N for neither.
Are we allowed to use the chart right here?
No. Because on a quiz or test, you wouldn't have the chart. Think through your divisibility rules to figure it out. If you can't think of a number you can divide it by, then it's probably prime.
You said 7 through 18.
7 through 18, yeah. Griffin's finished already. He makes up his mind quickly. A man of quick decision.
I'm dead.
You made up your mind who you're going to vote for in the next election yet? It's like I have. I'm just not allowed to vote yet. Yeah, with it being a church night, I did not get to watch the GOP debate last night, but I am very curious to watch it. So I am not sure who I've got my support for. I do not like Joe Biden. If you like him and you're watching on YouTube, I'm sorry. I mean, open your eyes a little. But anyway,
Yeah.
just got 5 dislikes on this video. As far as the GOP field, I'm like, okay, who do I like best? I don't know. Wait and see. I'm very interested to watch that debate. All right, let's see how we did. Number 7. What was your verdict, man of quick decision?
Composite.
Composite. Said with confidence, too. Griffin for president. All right, number 8. 37. What's the verdict on that, Elaine?
Prime.
Prime. How about 31, Ben?
30.
Number 9. The number 31. Follow along with me.
P.
P, prime. Okay, so we use the word. I know you wrote it, P, but go ahead and say prime. So let's rewind. All right, 31 then is
Prime.
66, Kirsten.
Composite.
Composite, 76. Michael,
Prime.
76.
Composite.
Composite, it's an even number, so I at least know there's a 2 in there. Number 12 was 1. Corey?
Neither.
Neither. 62, Jalen.
Composite.
Composite, 19, Paige.
Prime.
Prime, it's one of the ones we memorized. 17, Sam.
17. Composite.
No, okay, it's number 15. We're going in order. Follow with me. The number 17, which is problem number 15, is
15 or 17?
okay. Problem number 15, if you're following with me, is the next problem we're doing. It's problem number 15. But the number I'm asking about is the number 17. What is 17? Is it prime or composite? It is prime. Now, the number 3, Samuel, is that's the next one. 3 is prime. The next one, 45, is composite. There we go. And then Bryson, 25 is
Prime.
ooh, 5 goes into it. Careful there. That is composite also. All right. Questions on these? I know it gets confusing with the numbers and all, but make sure if you're following along with me, it should not be confusing. Questions on 7 through 18? How many got all of them right? Not only is Griffin quick with his decisions, he is right with his decisions. Griffin, 2032 or 2036, whenever you're able. Actually, you got to be like 35 years old or something like that to run for president, so it's going to be a while. Anyway, but if I see Griffin on the ballot, I'll know it's you. All right. All right. Next thing, look across the page, if you would, at page 14. One of the things we can use prime numbers to do is to break numbers into their smaller parts. Any composite number can be broken into a group of prime numbers that multiply together. For instance, look at the example that they have there. They use the number 48. It can be broken into smaller primes. What we're going to use is a process called division of primes, and you see it there. Rather than using the conventional division house, we're going to use an upside down division house. And we're going to divide by the smallest prime number possible. Well, class, what is the smallest prime number?
2.
2. So we're going to try dividing by 2. And we should be able to do this largely in our heads. 2 goes into 4 with nothing left. 2 goes into 8.
4.
4 times. Okay, so that's 24. Is that a prime number, class?
No.
No. So we're going to continue dividing. Once again, 24 can be divided by 2. 2 goes into 24. 12 times. We memorized that one. That's also still not prime. We're going to keep dividing until we get a prime number. Once again, we can divide by 2. 2 goes into 12. 6 times. It's small, but it's not a prime number. We can divide again by another prime number, class.
2.
2. And we get
3.
Is that a prime number?
Yes.
Yes. So the prime factors of 48 are 2 times 2 times 2 times 2. Wait, 2 times 2 times 2 times 3. 4 of the 2's. Times 3. Notice I use the raised dot instead of the X because it's faster. And I am lazy. I don't believe this one's in your book. 36. Let's prime factor it. What's the smallest prime number, class?
2.
Can 36 be divided by 2?
Yes.
Because it's even. So let's divide it by 2. Call it when you know what it is.
18.
Ooh, several of you really quick with that one. 18. Can that be divided by 2?
Yes.
Good. What do we get? We divide it by 2. 9. All of us should have that one. Can that be divided by 2, class?
No.
Ooh, is it already prime?
No.
No, there's a different prime number. If 2 doesn't work, go with the next smallest prime.
3.
3. All right. What's 9 divided by 3?
3.
Is that prime?
Yes.
So we're done. So we would say that the prime factors of 36 are 2 times 2 times 3 times 3. Composite numbers can always be broken down into a series of prime factors. How about this one? If we have the number 45, what's the smallest prime number that I can use on a 45?
3.
3, not 2, right? It's not even. Now, 5 is a prime number. It could work, right? I like to use the smallest prime so it keeps the numbers in order. 3 can go in, think about 45 minutes on a clock. That's 3 sections, if you will, of how many minutes? 15 minutes, 3 15-minute intervals, right? 3/4 hours. Can 15 be divided by a 3 again, class?
Yes.
Yes. To get?
5.
Is that a prime number?
Yes.
Then what would we say the factors of 45 are, class?
3 times 3 times 5.
Did you do division of primes last year in 6th grade?
Yes.
Some of you are saying yes, some of you are saying no. Some of you have a pretty good idea of what you're doing at least. Let me have you try this. On page 15, notice how they did most of the prime factoring for you on 19 through 22. I just need you to finish the prime factoring here. Just find that last digit and put it in the blank. Should not take long. But as you're doing it, especially if this is new to you, kind of notice what they did to arrive at their prime factoring. Question? Which question? Go ahead. Question?
When you have a lot of numbers, you just do like
We'll get into that tomorrow. We will get to that. All right, let's take a look at number 19. What's that last prime number that finishes the process for us, Paige?
3.
A 3. For number 20, what's that last number, Jalen?
5.
5. For number 21, Kirsten, what's the last number?
3.
And for number 22, Ben, what's the final number?
7.
A 7. And again, we have to end with a prime. And notice what they've got in the listing. They've got prime numbers listed all together in little groups, smallest to largest as they progress. Now, you get to do this on the next couple of problems. I want you to turn the page and do 23 to 26. You get to do the whole prime factoring now. All right, so 23 to 26. Give it a try for a few minutes. If you're stuck on one, go on to the next one. Okay? I feel like most of you, 23 is the hardest of the 4 I just assigned. So maybe you skip 23 for now and do 24 through 26, and if you finish early, go back to 23. We're doing 23 through 26 in no particular order. Again, if 2 can work, divide by it. If it doesn't work, maybe 3 does. If it doesn't, 5 maybe. If not, 7. And just keep using small primes until you get it down to a prime number. People already finished. Some of you still working, that's fine. Good job. That's right. Good. Now here, you divided to get 9, and then you divided the 3 by another 3, didn't you? So just like you put a 3 beside the 27, you put a 3 beside the 9. So we actually put a 3 if we don't. Okay, we're doing these ones. So 23 to 26. Now go down the other one. 3, 5, 7. So it's okay to use the 7 here. But you can't use the 4. So we do those ones without performing list of factors.
So do I do this dot product like that?
Oh, yeah, you want a factor. That might become the factor. Just another minute. Several people already finished. So we'll take just another minute to work on these, then we'll go over them together. Alright, pencils down. Even if you're not finished, several of you already are. Pencils down. Let's take a look at these together. But before we do, let's say our first 8 prime numbers together again, class. 2, 3, 5. 9 is not prime. 11.
13, 17,
There we go. Let's say them again now that they're on the board. 2, 3, 5, 7, 11, 13, 17, 19. You have to pick one of these to do your division, preferably the smallest one possible. So as I look at, I'm going to start with 28. We'll say 56 for a minute. Starting with 28, which is the best number to start the division with? Corey? 2. I'm going to divide 28 by 2. What do I get, Kirsten? 14. Now, which of these numbers should I divide by now then?
7.
I could, but the best number is the smallest one. But let's just go with 7, okay? It's not wrong as long as it's a prime number. 7 would give us what here? Then a 2. Now, the only thing is, they're all jumbled now. When we list them, we want to list them with the smallest numbers first. So we'll say 2 times 2, and we'll put the bigger 7 last. That's the only downside of getting them out of order a little bit. But it's, I think we can rearrange the order just fine, right? So it's not a problem whatsoever. How many had 2 times 2 times 7 is your prime factoring of 28? Excellent. Let's take a look at 35. Which of these numbers should we use in the prime factoring of 35, Bryson? 5. And we divide 35 by 5, we get
7.
7. Is that prime? Then we're done with the factoring, and so class, the factors of 35 are?
5 times 7.
5 times 7. For 27, which of these numbers should we use first, Luciana? 3. And we divide by 3, we get? 9. Is that prime, class?
No.
No, then we are not done. We have to divide again. Luciana, this time use? 3 again. And it gives us 3. And that's prime, so we're done. So what's the prime factoring of 27, class?
3 times 3 times 3.
3 times 3 times 3. How many had that for number 26? Let's come back to 56. Technically, Jalen, what number should we use? We should use 2, right? But going back to what I pointed out with Ben earlier, as long as it's one of these numbers, it's okay. And which of these numbers is maybe a little easier to use, Jalen?
For me too.
Okay, so for you too. Okay, then we'll roll with 2. Many of you probably use 7, some of you, and that's okay. 2 works. Let's cut it in half. We just got to be careful here. 2 goes into 5, Jalen.
28.
Okay, twice with 1 left and into the 16 8 times. So we get 28. And then we can divide that by 2 again to get
14.
And then class, we can divide that by
2.
2 to get
7.
7. And so the prime factors of 56 are, class?
2 times 2 times 2 times 7.
And there we go. How many had that for number 23, that first one? All right, questions on that? Any questions on prime factoring using division of primes? All right. We'll practice a little bit more in the homework tonight with this. Your homework is page 17, numbers 1 through 20. Page 17. I want you to do the homework section 1 through 20. You've already done the 21 through 27 to end it out, but you're doing 1 through 20. Also, look over what are called fast facts on pages 14 and 15. There are little sections in this textbook of some extra insight called fast facts. I want you to look at those on pages 14 and 15. We're going to talk about them tomorrow. But your written homework tonight is page 17, numbers 1 through 20. Page 17, numbers 1 through 20. We'll look over the page 14 and 15, fast facts. We'll go over more of that tomorrow. Have a wonderful rest of your day. When the bell rings, you'll be dismissed.